Hello, we are on day 11 of STAAR View. Today we are starting volume and surface area. That topic. In this topic on your STAAR test, there's going to be about 5 questions regarding volume and surface area. There's going to be 2 questions over volume, 2 questions over surface area, and then there might be a question over the volume formula for cylinders. So before we get started in the notes, I want to point out some resources you have in your STAAR View folder. In your STAAR View folder, you have your STAAR reference material. And then on here, we've already talked about area, surface area, volume. These right here are the formulas that you might need for volume and surface area. We've talked about this pretty recently, so you should be somewhat familiar with the formulas and what those variables mean. Another resource that you have in your folder is your study sheet on the back side. Right here, we have surface area section and then a volume section right there. So you have that available to you for help as well. All right, so since we did just learn about volume and surface area, I really just want to refresh your memory on the formulas, what the variables mean, and what it's asking for. So this first page, page 21 in your packet, it's about surface area. So there's 2 different types of surface area. There's total and lateral. So total surface area means the sum of all the faces, including the bases. Lateral surface area is the sum of all the lateral faces, but not the bases. So total includes the bases, lateral does not. That's the difference between the 2. So our bases, looking at the 3 shapes, we have a rectangular prism, a triangular prism, and a cylinder. Our bases, for example, are whatever that first word is, especially for the 2 prisms. So we got a rectangular prism and a triangular prism. The bases for the rectangular prism are right here. The base for a triangular prism is the triangles. And then the base for a cylinder is the circles. So those are the 3 shapes, those are the bases. The height of those shapes is the distance between the 2 bases. So if this is a base and this is a base, the distance between them is that right there, right? What connects the 2 bases. The triangles for a triangular prism are my 2 bases. So this right here that connects those 2 triangles, that's my height. That's the height of my prism. And then same thing with the cylinder. The height is the distance between the 2. So we have different formulas. We have a lateral formula and a total formula for a prism, lateral formula and a total surface area formula for cylinders. So P in the formula stands for the perimeter of the base. So for my prisms, I need to find the perimeter of that rectangle right there. That's my P. So right here, if I were to draw this rectangle out to the side, I got 18, 18, 9, 9. If I add up all those together, my perimeter is 54 inches. My height is 14. And then big B stands for area of the base. So how do I find the area of a rectangle? I do base times height, or length times width. 18 times 9 gives me 162. So once I'm able to identify these variables, I can plug them into the formulas to find the lateral and total surface area. I can do the same thing with the triangular prism. I find my perimeter, so my perimeter of my triangle, I add up the 3 sides, 10, 10, 12, right? Add those together and I get 32. So there's my perimeter. My height we already identified as 21. And big B is area of the base. Well, my base is a triangle, so I do the formula for the area of triangle, which is 1/2 base times height. So I got 1/2. The base of my triangle is 12, and the height of my triangle is actually 8, right? That's the height of my triangle. So there's my big B. And then once I know all 3 of those things, I can plug them into whatever formula I need to solve for either lateral or total surface area. The cylinder is a little bit different. It has a different formula. So my formula for lateral and total surface area is this. The 2 variables that we need to know is our R, which is our radius, which is halfway across the circle, and my height of my cylinder, which is the distance between the 2 circles. So in this example, my radius is 5, that's halfway across my circle, that's my R, and then my height is 15, and when I plug them into my formulas, I can find my lateral and total surface area. So that's surface area. On the back of that page, we're talking about volume. So volume is the amount of space inside a solid. The 3 shapes that we learned about this year are cylinders, cones, and spheres. And what's important that we know is what the variables mean, and how can I find that information in the shape. So for a cylinder, the volume formula, which you can find on your STAAR chart, is V equals big BH. Big B means area of the base. Well, my base is a circle, so I can plug in the formula for the area of a circle for big B, and then I multiply that by the height. So in this case, my R is 4 and my height is 12. And then I plug that information into the volume formula, and then plug that into my calculator. Cones, right? My formula is V equals 1/3 big BH. Again, big B means area of the base. So my base is a circle, so I'm using the circle formula for big B. I'm just plugging that in for big B. So now, all I need to know is my R and my H to solve for volume. Well, my R is still halfway across the circle, which is right here. My R is 8, my radius is 8, and my height is the distance between the circle to the point of the cone. So I have my R and my H. I can plug those values into my volume formula and plug that into my calculator to solve. For spheres, the formula is V equals 4/3 pi R cubed. This one's really easy because all you need to know is the radius. Again, the radius is halfway across the sphere. So in this case, my radius is 9. So then I can just plug this into my formula. 4/3 pi 9 cubed, and then I can type that into my calculator real quick. I feel like we're pretty confident with squaring a number, but this one where it's cubed, I want to show you real quick how to plug that into your calculator. So we have 4/3 pi 9, and the way we put the cubed or the exponent, that's 3. Any exponent that we want to put in. This right here, this little rooftop looking button, you click that, it creates an exponent box. We can type in whatever number we want. I'm going to type in the number 3 because I'm cubing that 9, hit enter, and I get 3053.63. So that is surface area and volume of 3D figures. You're going to finish the assignment on Google Classroom.